Hello my lovely students, you are welcome to a new lesson. Today I shall be teaching you mensuration and we shall be looking at compound solids and frustum. From definition, compound or composite solids are shapes made up of a combination of other basic solids in different forms and sizes. Also from definition, a frustum is a truncated cone or pyramid. This is as a result of cutting a cone or pyramid through a parallel to the base and removing the part containing the apex or the vertex. Let's learn more about compound solids and frustum. Surface area and volume of compound solids. From definition, the surface area of a compound or composite solid is the sum of the surface areas of its components. Subtract the area of the hidden faces from the total surface area of the components. Also from definition, the volume of a compound or composite solid is the sum of the volumes of its components. In a compound or composite solid, the volumes of the component solids are added together or subtracted in the case of hollow shapes. Let's see some formulas for the surface area and the volume of a frustum. Here we have the frustum of a cone. For the formulas, the total surface area of the frustum of a cone is the area of the top circle, which is the top area, plus the bottom circle, which is the bottom area, plus the curved surface area. Formula for the total surface area of the frustum of a cone is pi radius squared, talking about the small radius for the small circle, plus pi radius squared, talking about the big radius for the big circle, plus pi into big radius plus small radius times the slant side or the slant height. Now using Pythagoras formula, we can get the value of the slant height as the square root of h squared, which is the perpendicular height squared, plus in brackets big radius minus the small radius, all squared. For the volume of the frustum of a cone, the formula is 1/3 times the perpendicular height into pi small radius squared plus pi big radius squared plus pi small radius times big radius. This can factorize into 1/3 pi perpendicular height in brackets small radius squared plus big radius squared plus small radius times big radius. From the diagram, we can see that the small letter r represents the radius of the small circle, while the big letter R represents the radius of the big circle. L stands for the slant height, while H stands for the perpendicular height. Please take note of these formulas. Moving on, let's consider the frustum of a square-based pyramid. Here from the formula, the total surface area of the frustum of a square-based pyramid is the top area, which will be a square, plus the base area, which is also a square, plus the area of 4 trapezium surfaces. This will give the total surface area of the frustum of a square-based pyramid as a squared plus b squared plus 2 into a plus b times the slant height. From Pythagoras' rule, the slant height can be gotten from the formula the square root of h squared plus in bracket b minus a all squared divided by 4. While the formula for the volume of the frustum of a square-based pyramid is 1 over 3 h in bracket a squared plus b squared plus ab. From the diagram displayed here, A represents the side of the small square, B represents the side of the big square, L represents the slant height, while H represents the perpendicular height. Please take note of these formulas. Now that we have seen the formulas, let's solve some problems. Example 1. The compound solid below consists of a cone attached to a cylinder of the same radius. Calculate the question A, total surface area, question B, the volume of the compound solid in terms of pi. Let's see the solution to question 1A. To solve for the total surface area of the compound solid, the compound solid here is made up of two component basic solids. So the total surface area will be the core surface area of the cone on top plus the surface area of the open cylinder at the bottom. That brings us to the core surface area of the cone on top, the formula being pi radius times the slant height, plus for the open cylinder at the bottom, the surface area of the open cylinder, the formula is pi radius squared plus 2 pi radius height. Looking at the parameters in question 1, we are solving in terms of pi. So pi equals pi. The radius of the cone and the cylinder is 6 centimeters divided by 2, because 6 centimeters here is the diameter. So to get the radius, divide 6 centimeters by 2. The radius is 3 centimeters. The height of the cylinder, capital letter H, is 10 centimeters. The height or the perpendicular height of the cone, small letter h, is 4 centimeters. But the slant height of the cone is unknown, and we need the slant height to calculate for the total surface area of the compound solid. So using Pythagoras' rule, the slant height of the cone, L, equals to the square root of h squared plus r squared. H here is the height of the cone. The height of the cone. So the slant height of the cone becomes h squared, which is 4 squared, plus r squared, 3 squared. That gives the square root of 16 plus 9, which is the square root of 25. The slant height of the cone is 5 centimeters. Now substituting all these values into your formula for the total surface area of the compound solid and calculating, you are going to get the total surface area of the compound solid as 84 pi centimeter squared. 84 pi centimeter squared. For question 1b, solving for the volume of the compound solid. Once again, the compound solid is made up of two component solids, which is a cone and a cylinder. The volume of the cone is 1/3 pi radius squared height, while the volume of the cylinder is pi radius squared height. Small letter h for the height of the cone and big letter H for the height of the cylinder. So solving by substituting the required values into the formula, the volume of the compound solid becomes 102 pi centimeter cube. 102 pi centimeter cube. This is gotten from the addition of the volumes of the separate component solids that is coming together to make the compound solid in question 1. I hope the solution in question 1 is clear to you. Let's solve our second question. A bucket is 40 centimeters in diameter at the top, 20 centimeters in diameter at the bottom, and 24 centimeters deep. Calculate in terms of pi. Question A. The area of material required to cover the core surface of the bucket. Question B. The volume of the bucket. Let's see the solution to question 2A. And in question 2A, we are required to solve for the core surface area of the frustum of a cone. The bucket here is actually the frustum of a cone. The formula for the core surface area for the frustum of a cone is pi into big radius plus small radius multiplying the slant height. Now to get the slant height from Pythagoras rule, it is the square root of a squared plus in bracket big R minus small r all squared. Don't forget we are calculating in terms of pi, so pi is pi. The big radius is 40 centimeters divided by 2 because 40 centimeters is the diameter of the big circle. So the big radius, big R, is 40 cm divided by 2, which is 20 cm. Small radius is 20 cm divided by 2, which is 10 cm. While the perpendicular height h is 24 centimeters. Substituting these values into your formula and calculating the core surface area of the bucket, which is the frustum of a cone, is 780 pi centimeter squared. 780 pi centimeter squared. Moving on, let's see the solution to question 2b. To solve for the volume of the bucket, the volume of a frustum of a cone, the formula is 1/3 pi h into small r squared plus big R squared plus small r times big R. Substituting the values for these parameters into the formula and calculating the volume of the bucket in terms of pi is 5600 pi centimeter cube. 5600 pi centimeter cube. I hope question 2 is clear to you. Moving on to our third question. A frustum of a pyramid is 60 cm square at the bottom, 6 cm square at the top, and 12 cm high. Find the volume of the frustum. The diagram for the question is displayed here. Let's see the solution to question 3. The volume of the frustum of a square-based pyramid is 1/3 bracket a square plus b square plus ab. That's the formula to apply here. From the diagram, A, which is the side of the small square, is 6 centimeters. B, which is the side of the big square, is 16 centimeters. While H, which is the perpendicular height, is 12 centimeters. Substituting these values into your formula for volume of the frustum of a square-based pyramid and calculating, the answer here for the volume of the frustum of a square-based pyramid is 1552 centimeter cube. 1552 centimeter cube. I hope these solutions, they are all clear to you. Thank you very much for going through the lesson today. I want to advise that to get more information about the topic measuration, compound, solids and frustum, continue to read your textbook. Don't forget to attempt your quiz and your assignments. I hope to see you again in our next class, and until then, it is goodbye for now. Thank you very much.